This is part 2 in my look at Vectorization Advisor, also known as Advisor XE. So today we're going to take a look at trip counts, how to measure them, and what they mean. Then we're going to take a look at how you can get even more detail on the loops that Vectorization Advisor has provided. We'll take a good look at loop dependency and what that means to your application. And finally, we'll take a look at data alignment and how that affects vectorization. Okay, so let's take a look at some code. First, I want to point out that I am in 64-bit release mode, and in order to make this real and get the metrics that are going to matter, I want to go ahead and be using release mode. Okay, so as you can see, this code is fairly simple. I've got a nested loop that's just kind of setting up this A array, and then I've got another loop that's setting up B and C. Okay, so make sure it's compiled, and it is. And I know that I continue to call this Vectorization Advisor because that's the way I look at it, but here in the menu it's going to be called Intel XE 2016, or whatever year you're using. Okay, so we're going to click on Start Survey Analysis, and it's going to run the program and then collect the metrics. Okay, and as you can see, it's got 3 loops that are identified. Notice that these 2 loops are definitely vectorized, and as I hover over them, it gives me quite a bit of extra information. Okay, so what I want to do first is collect trip counts, and this is going to collect the data that's going to tell me how many times these loops have actually been iterated through. Now, the reason this might be important is if you have a large application and you need to kind of pick and choose where you start and where you spend your time on, you're going to take a look here at trip counts and try to identify the ones that are going to give you the biggest bang for your time buck. Okay, so that's one of the reasons that the trip counts are so important to know. Okay, notice that this loop here is not vectorized at all. Now we'll take a look at the source code here, and that's an outer loop. And in general, the compiler is not going to vectorize the outer loops anyway. And we don't even need it to vectorize. It won't do us any good anyway. We could force it to vectorize, but it won't make any difference. Okay, so let's talk about stuff that might prevent your vectorization from being optimized. Notice that this second loop has an efficiency of 57%, and there is a vector issue that's listed here. So we'll click on that, and it says recommendation, use the smallest data type. So let's take a further look at our data types, and this vectorization is using float 32 and float 64. Or in other words, those are a C float type and a C double type. So that gives us a clue on what we can do to fix this and improve the efficiency. So let's go here. Aha! So by default, the compiler is going to make that a double. So all we need to do here is cast that to a float, so then we can match all of our data types. Okay, let's go ahead and rerun Vectorization Advisor. And it runs the program, regathers the data. Now notice that that loop has 100% vectorization efficiency. It's only got a single data type, and that message has disappeared. This other loop is using float 32 and int 32. So what we can do if we have a large program, just go through one at a time and fix these issues. And here again, I would definitely use the trip count to try to identify where you should spend most of your time. So let's take a look at another situation you might encounter. Now I have reworked that second loop, and you can see that there's absolutely no vectorization. So let's go ahead and take a look at this and try to figure out why. We click on there and it's going to tell us and advise us what to do. It's going to say that this loop will not benefit from vectorization. Okay. Common reasons, non-unit stride memory access, and actually that's going to be the correct reason. Let's just take a look. So notice now instead of incrementing by 1, we're adding 2. So this is where the stride is going to prevent us from vectorizing. Okay, another thing I'd like to point out, while loops are very difficult for the auto vectorizer. So in these cases, what I'm saying is there's nothing you can do about this. This can't be vectorized, but maybe you can restructure your code so that you don't have to face these issues. This video really just scratched the surface. Vectorization Advisor is a very rich tool that can come to your assistance many, many times. We saw ways to identify vectorization issues. We saw ways to use the Vectorization Advisor in different ways. We also saw times when you may just need to go ahead and restructure your code.